gases in the atmosphere. So let's get straight into it. So over here we've got a little table, and this is showing you the elements that are present in air. And as you can see, it's dominated by nitrogen and oxygen, and the rest is sort of filled up with other noble gases and carbon dioxide. Now, this is important to know that it is a dry sample of air. It's unpolluted as well. And what's important to also be conscious of is that there is a rising amount of carbon dioxide in our atmosphere, and this is obviously due to global warming and climate change. And that generally speaking, in a sort of environmental sample of air, there's 0 to 4% of water vapor. So these are the sort of raw facts that you need to know. And the next thing you need to know is some experiments to sort of prove how oxygen takes up 21% of this air. So how did they prove that? How did they get to that percentage? They use an experiment that I'm going to show you over here. So what we've got on the left-hand side and the right-hand side is we've got two syringes. So we've got two syringes here that you can change the amount of air. So there would be air occupying this space. And on this side, there is zero air. Okay, so the syringe is pushed all the way through. And on this side, we've got the syringe pulled out to 100 centimeters cubed of air. Okay, now what we've got in the middle here is a little tube that contains copper. So over here is just pure copper, okay, in its solid form. And what we're going to do is we're going to take a Bunsen burner, a roaring flame, nice blue flame, and we're going to apply some heat to this copper, okay? And as we're doing that, we are going to push this side in and sort of get the air that's in the section to, for lack of a better word, sort of wash over the copper. And as it washes over, it's going to create the copper and the oxygen that's present in the air to create copper oxide. So as soon as we start doing this, as soon as we start pushing from this side, it's actually going to create this black compound, copper oxide, in the middle. Okay, and then once we've pushed this all the way to the side, and so if you can imagine sort of this being pushed all the way to here, we're then going to, obviously, this side is going to then push out towards that way. And then we're going to push this side back, and we're going to go back and forth and back and forth. And we're going to do this until basically these sides balance out. And what we've got here is we've got an experiment that shows us initially, so the initial volume is 100 centimeters cubed as we measured. And by the time the experiment has been completed, the final volume inside here will be around sort of 79, round about over there, 79 centimeters cubed. And if you minus these two from each other, you get 21 centimeters cubed, and we've used a total of 100. So this gives us the percentage of oxygen that has reacted with the copper oxide. So I'm going to show you a YouTube quick on this actual experiment. You can have a look here. Let's just skip on ahead. So here's the sort of theory that I've just taught you about. So there's the roaring Bunsen burner, and we've got the tube filled with copper, and we've got copper oxide that is forming. Now you've got these syringes on either side, and you can see we are now pushing that syringe that way. The other syringe then moves the other way on the other side, and then she's pulling it this way, and she's going to continue to do this back and forth. You can see the 100 mils on this side, and she continues to do it. Let's just skip on ahead. It's important to have a look at this reaction quickly. So it's obviously a balanced equation. Copper oxide is being formed, and we've got copper and oxygen as the reactants. And you can see that black copper oxide starting to form. And you go on and on and on, and eventually you work out that the final volume that is left in these tubes is 21% of oxygen. So that's fantastic. Let's go back and have a look at another experiment where we can talk about using the rusting of iron to determine the percentage of oxygen in air. So what we've got here is just a trough full of water. So this is the sort of this is the original water level over here. and we've got an upside down boiling tube, and over here we've got some steel wool, or as they say in many textbook, iron filings. Okay, so we know that iron, Fe, is also it reacts with oxygen to produce iron oxide. We know this, right? So in this section of the boiling tube, we have air, okay? And we know that air has oxygen inside of it. Now, if we had to leave this apparatus, if we had to leave it for about a week, what you would start to see is that this iron starts to rust. In other words, it starts to react with the oxygen. And as the oxygen is used up in the space, you can imagine that there's less stuff there. There's less stuff for the space to occupy. So what's going to actually happen is if there's less space here, because it's always been taken up by the iron filings, the water level in this boiling tube is going to then rise. So here's the sort of original water level, and as the oxygen reacts, we can see that the oxygen level rises. So this is the new water level over here. And this is another experiment to show, okay, well, if I measured this volume over here, if I got a reading for this water level over here, and say the reading was, I don't know, 100 centimeters cubed, and now the new reading is 121 centimeters cubed, we would know that it's used up 21 centimeters cubed of air, or of the actual oxygen that's in that air, and then we would be able to work this out as 21% oxygen. So these are two experiments that involve determining the percentage of oxygen, which is the fact that you need to know from gases in the atmosphere. There's a few more experiments that we're going to talk about, but we're going to save those for a new video. I hope it was very helpful, everybody.